Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, TIFR, Jest, IIT-Jam and other exams related to physical science. Okay, so this is the lecture number third of condensed matter physics. Okay, so we are studying crystal structure, and this is the third part of the crystal structure. Okay, so I'm going to start, and also I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live classes, which are going to help you to crack the exams related to physical science. Okay, so I'm I'm going to discuss hexagonal closed pack structure first. Okay, SCP structure. Okay, so hexagonal closed packed structure. Okay, hexagonal closed packed structure, that is SCP. Okay, this we are going to study. So I'll make a figure first. Okay, diagram. Okay, I'm just trying to make it. Okay, this is one. Okay, just be like this. Okay, so these are the corner atoms of hexagonal closed pack structure. Okay, these are corner atom. Okay, and there are the face. So there are two atoms on the face. Okay, and like this, and this distance is also a, guys, and this distance is a. This distance is a. This is a. This is a. This is not looking, but these distances are a. Okay, and this height is c, guys. Okay, height is c. Height is c. Okay, so this one. Okay, so here we'll find first effective number. Okay, and effective we know that we know, right, that is 1 by 6 into 12 total corner atoms, right? These are 12 6 atoms. Okay, plus face atom, right? So the atoms on the face, that is 2 by 2. Okay, and plus 3 atoms are at center, guys. Okay, 3 atoms are at center. These are, okay, so that is Ni. Okay, so if you solve it, this is going to be 2 plus 1 plus 3. So N effective for hexagonal closed pack structure is 6. Okay, very important, guys. So this is the N effective for the hexagonal closed pack SCP structure. Okay, and now in this case also atomic radius. Okay, atomic radius. Here A is equal to 2r. So from here atomic radius r is going to be a by 2. Okay, a by 2. Okay guys, so this is a by 2 and this is so r is atomic radius and a is the side of the hexagon. Okay, well, so this is important result. These are important results guys. Okay, so use it. Okay, next is nearest neighbors. Okay, nearest neighbor for SCPs. Nearest neighbors equal to 6 plus 3 plus 3. Okay, that is 12. Nearest neighbors are 12. That is coordination number for hexagonal closed pack structure is 12. Okay, or coordination number we can write CN. Okay, coordination number. Okay, coordination number is nearest number of nearest neighbors. Okay, well, now C upon A equal to root 8 upon A, guys. So okay, this is very important. C is the height of the hexagonal closed pack structure. Okay, so this is the height C and this is the side A. Okay, so C upon 3. Okay, root 8 upon 3, very important result. And from here we can find value of C. Okay, this implies value of C is going to be A root 8 by 3. A root 8 by 3. Okay, now we'll find volume of the unit cell. Okay, volume of the unit cell of SCP. Okay, so unit cell of SCP is going to be, this is SCP guys, this one. SCP is going to be here. So this is volume is area of base into height, right? This, you know, volume into height, area of base into height. Okay, that is the volume. That is the volume. Well, so base, area of base is, look at here. So area of base means this area, right? And this area we know in hexagon it is this hexagon is made of 6 triangles, right? 6 triangles. So and all 6 triangles are equilateral triangles, which I have already explained, right? So it is going to be 6 into area of triangle. We know that is root 3 by equilateral area of triangle of equilateral triangle is 3 by 4 a square, right? This is 3 by 4 a square. These are a side, are sides, all sides are a in hexagon, right? So 6 into root 3 by 4 a square, that is area of one equilateral triangle. Okay, side is a, into height is C guys, height is C, this one height is C. So this is going to be, if you solve it, so this value is going to be 6 into 3 root 3 upon 4 a square into, here we'll put the value of C. Value of C is root 8 upon 3 into a, right? This value we have put it, and if you solve it, this is 2 root 2 guys. 2 will get cancelled and 2 will get cancelled, this 3, right? 3 will get cancelled. So this value is going to be uh, 3 root 2, okay, 3 root 2 a cube, okay, because this is 2 root 2, guys. 2 will get cancelled, right? And uh, and this will get cancelled 2, right? So this is going to be 3 root 2 a cube. Now this a cube value we know, this is going to be 3 root 2 into 2r cube, because here I have already explained a is equal to 2r, so r equal to a by 2, a equal to 2r, so we'll put 2r instead of a. So 3 root 2 into 2r cube, okay, 2r cube. Now we'll find APF, right? Atomic packing fraction, APF for hexagonal SCP. Okay, so APF means volume of each atom, right? And effective into volume of each atom means 4 by 3 pi r cube, right? Upon volume of unit cell, r cube will get cancelled, right? And this will get cancelled, and this value we are going to get pi by 3 root, guys. Okay, if you solve it, very simple calculation. Okay, so 3 will cancel by 2, 2 is going to cancel with this 4, 4 will get cancelled this, and this is going to be pi by pi upon 3 root 2. Okay, and if we get this value in percentage, this value is almost equal to 74%. Okay, 0.74 or 74% as FC, as FCC. We have seen the atomic packing fraction of FCC is also 74% as it is for SCP. Okay, so atomic packing fraction of FCC and SCP, that is hexagonal closed pack structure, is same. Okay, next point is coordination number. Okay, coordination number, and we know here, right, coordination number we have already found, that is 12. Okay, so here we can see, since I'll write here, since we can see, right, coordination number is greater than 12, right, greater than equal to 12 in this case, and APF is greater than equal to 74%, right? I have explained in my last lecture. And N effective is, we can see N effective is greater than equal to 4, because N effective is 6 here, right? If this condition gets satisfied, it means that structure is closed pack structure. Okay, so this means this tells that SCP is, it is also clear from the name, guys. Okay, so it is closed pack structure, closed packed structure, closed packed structure. Okay, well, so let me just check whether I am audible or not, then I'll proceed further. Root 2 a cube, yes, I'm audible, so I'm going to proceed further. Okay, guys, next is I'm going to write this primitive cell. Okay, write about primitive cell. So primitive cell, primitive cell. So N effective is going to be for primitive cell, for one primitive cell. Okay, N effective means effective number of atoms. Okay? N effective for one primitive cell, one primitive cell. Okay, N effective for one primitive cell is 1 upon 8 into 8 plus 1, right? Okay, 1 upon 8 into 8 plus 1. So that is 2. Okay, and primitive lattice vector for it, and primitive lattice vector also you should know. For one cell, it is primitive. An effective for primitive cell is this. Okay, and primitive lattice vector. Primitive lattice vector. Primitive lattice vectors are for primitive cell. Okay, primitive lattice vectors for primitive cell are this is A equal to, you need to note down, okay, and learn it. Value of B is A j cap. Value of C is C k cap. Okay, and value of A is, that is A by 2 root 3 I minus 3. Okay, this is A equal to B equal to A j cap and C equal to C k cap. Okay, and A is A by 2 root 3 I minus 3. Okay, this is the primitive lattice vectors for primitive cell. Okay. Well, so this is the one, so I can show you this as well, like this, for one effective. Okay, is okay, this height, this height, this one, this center, this one, this one. Okay, and here this one. Okay, there is this, and yeah, at the center, and here and here. Okay, these are the atoms, and this part is this part is this part, right? This part is primitive lattice. Okay, this one. So this is at face side. It is at center. Okay, so that's why there are 8 in corner. Okay, 8 in the corner and 1 here. Okay, so this is the n effective for primitive. This is primitive cell, guys. Okay, this is primitive cell, and the primitive lattice vectors are A equal to A j cap, and this is the height C, guys. Okay, A is the side of the hexagonal SCP. Okay, so A is B equal to A j cap, C equal to C k cap, and A equal to A by 2 root 3 I minus 3. Okay, well, this is about the primitive lattice vector. Now we'll find primitive lattice vector for simple cubic BCC and FCC. Okay, so primitive lattice vector, primitive lattice vector primitive lattice vectors. Okay, primitive lattice vectors, primitive lattice vectors. Okay, primitive lattice vectors. So primitive lattice vectors for first for SC, that is simple cubic. Okay, simple cubic, simple cubic is primitive cell itself. Okay, so it is itself a primitive cell. Okay, so primitive cell itself. Okay, so SC is, that is simple cubic structure, is itself a primitive cell. Okay, primitive cell in itself a primitive cell. Okay, so it means vector A is going to be AI cap primitive, then primitive lattice vectors. Okay, vector A lattice vectors, primitive lattice vector are vector A, vector B, vector C. Okay, vector B is going to be AJ cap and vector C is going to be AK cap. Okay, because it's a primitive cell itself. Okay, now BCC, that is body centered cubic. Okay, uh, primitive lattice vectors are vector A, value is A by 2 I cap plus J cap minus K cap. This is the primitive lattice vector A. Okay, and then vector B is A by 2, A by 2, A by 2 minus I cap plus J, minus I cap plus J cap, minus I cap plus J cap plus K cap. Okay, and C is going to be a primitive lattice vector. C is going to be A by 2 I cap minus J cap plus K cap. It is in cyclic order. Okay, minus, first minus in K for A, then I, and then K I J. Okay, so C is A by 2 I cap minus J cap plus K cap. Okay, so these are the primitive lattice vectors of BCC body centered cubic structure. Okay, now for now we'll find volume of primitive cell, volume of primitive cell, okay, volume of primitive cell is BCC. Okay, volume of primitive cell means unit lattice vector, right? Okay, so the volume of primitive unit cell. Okay, that is volume of primitive cell, volume of primitive cell. So what will be the volume of primitive cell for BCC, volume of primitive cell? So this is going to be V equal to A dot B cross C, right? A dot B cross C, that is the volume of primitive cell for this. Okay, these are the primitive lattice vectors. So volume of primitive cell is going to be V equal to A dot B cross C. Okay, this is for BC and this is for this primitive cell, right? This is the primitive cell for this one, this hexagonal pack. Okay, SCP, and this is primitive lattice vectors for hexagonal closed pack structure. Okay, so so volume of primitive cell is going to be A dot B cross C, and we can easily find out that is A by 2, determinant of A by 2 minus A by 2, right? This we know how to find it, and this is minus A by 2, A by 2, A by 2, and this is A by 2 minus A by 2 and A by 2. This is the determinant, right? And this value is going to be equal to this is, if you solve it, this is going to be A cube by 2. Okay, A cube by 2. So here I'm going to tell you the trick, guys. This trick is only valid for this one, cubical structure. Okay, so trick is volume of primitive cell, volume of primitive cell, volume of primitive cell. Okay, for cubical structure, for cubical structure. of cubical structure volume of primitive unit cell for a cubical structure is equal to volume of unit cell, primitive cell means primitive unit cell, okay, volume of unit cell upon an effective, okay. So if we see this case, BCC case, it's a cubical structure. BCC, we know volume of primitive cell is A cube, right, and effective number in BCC is 2, right. So this is going to be so this is the volume of unit cell upon an effective, that is A cube upon 2. So this is a volume of unit cell upon an effective, and this is valid only for cubical structure, right. Similarly, we can get volume for that volume of primitive cell for uh, that FCC structure, okay. So now we'll talk about FCC, primitive lattice, primitive lattice vector for FCC, okay. Primitive lattice vectors means A vector, B vector, C vector, okay. So for for FCC, okay, so for FCC it is going to be this one. FCC primitive lattice vector A is A by 2 I cap plus j cap, and vector B is primitive lattice vector, okay, A by 2 uh, j cap plus k cap in cyclic order, and C equal to A by 2 k cap plus I cap, okay, k cap plus I cap, okay. So now volume, we can volume of primitive cell, volume of primitive cell, primitive volume of primitive cell, volume of primitive cell is going to be this one, that is we can directly get by this trick, okay. Volume of unit cell, that is A cube upon n effective for FCC is 4, okay. So this is A cube by 4, okay. This is the primitive lattice for FCC structure, okay. Very easy. Next is a diamond cubic structure, guys, okay. Diamond cubic structure. Diamond cubic structure, okay. Diamond cubic structure, okay. So I'll write about it. So diamond cubic structure, it is not a brevis lattice, okay. It is not a brevis lattice. It is not a brevis lattice. So diamond cubic structure, it's not a brevis lattice, okay. And 6 faces. So it has 6 faces. The atoms atoms are, so 6 atoms are on the faces and 8 atoms are the corner, okay, of carbon atom, okay. So I'll write 6 faces plus 8 corners, 8 corners, there is carbon atoms, okay, carbon atom. So this is like FCC, right. So there are 6 so so there are atoms, the carbon atoms in 6 faces of the diamond cubic structure, and 8 carbon atoms at the corner, okay. And and 4 inner carbon atom, and 4 inner carbon atom, 4 inner carbon atom, 4 inner carbon atom, okay, in the diamond cubic structure, okay, at tetrahedral site, okay, at tetrahedral site, okay. It's tough to show those 4 inner atoms in tetrahedral site, but I'll just make figures of figures, okay. So this is the diamond cubic structure, okay. This one, there are 8 atoms, carbon atoms at the corner, okay. This is, and 6 atom at the faces, okay. These are 6 atom at the faces, and there are 4 inner atoms, okay. 4 inner atoms, 4 inner carbon atoms in at tetrahedral sites, okay. Okay, so like this, okay, tetrahedral side, this inner side it's not possible to show, but yes, there are 4 tetrahedral, 4 inner carbon atoms in tetrahedral atom, right. So so we can see total atoms are 6, 8 and 4, okay. So now what we are going to get, that is n effective for it, okay. N effective, I have already explained formula, right, in my first lecture. That is NC upon 8, the number of corner atom upon 8, plus NF, the atoms at face, by 2, NF by 2, and plus Ni, atoms at center, right. So this is going to be, there are 8 atom, right, 8 by 8, plus there are 6 atom at the faces, so 6 by 2 plus Ni, at inner of the carbon there are 4 atoms, right, 4 atoms. If you solve it, this is going to be 1 plus 3 plus 4, so N effective is 8 for diamond cubic structure, okay. For diamond cubic structure, N effective is 8, guys, okay. Next is, and here it's very important one, this is for diamond structure, 8R equal to root 3a, okay. 8R equal to root 3a. From here we can get value of a is equal to 8 upon root 3r, 8 upon 8 upon root 3r, okay, or 8r upon root 3, okay. This is important, okay. We need to know. This is the relation between radius of atom and the side of diamond cubic structure, okay, cubic structure, okay. So now this is nearest neighbor distance for diamond structure, nearest, these are very important points, guys, and that are asked in the examination, so you need to note down and learn it, okay. Nearest neighbor, nearest neighbor distance is root 3a upon 4, okay. Nearest neighbor distance is root 3a upon 4, okay. Next, nearest neighbors, that is coordination number, okay. Nearest, the number of first nearest neighbors, okay. So nearest neighbors, NEI, nearest neighbor, that is coordination number is 4, okay. Coordination number is 4, or nearest neighbors, nearest, and the number of first nearest neighbor, we can say. So nearest neighbors, or coordination number is 4 for diamond cubic structure, okay. And now volume of unit cell, okay. Volume of unit cell is a cube, right, and a cube value we know here for this relation, right. A is 8r upon root 3, right? So this is going to be 8r upon root 3, 8r upon root 3 cube. Okay, so now we'll find out APF, that is atomic packing fraction. Atomic packing fraction formula we know, N effective into volume of each atom. Okay, pi r cube upon volume of unit cell A cube, right? So we'll put the value. So this is going to be 8 into 4 by 3 pi r cube upon, we'll put this value, right? This is A cube value is 8r upon root 3 cube. Okay, and this value is going to be root 3 pi by 6, root 3 pi by 6. Okay, root 3 pi by 6, root 3 pi by 6, and that is equal to 34%. Okay, so very less percent. Okay, 0.34 or 34%. So that tells that implies this is loosely bound, loosely packed structure. Okay, this is not closed packed structure, this is loosely packed structure. Okay, loosely packed structure. This is loosely packed structure. Okay, loosely packed structure. Okay guys, so I'm going to stop here today. Remaining part we'll do in next lecture. And also guys, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help you to crack the exams related to physical science. Okay guys, thank you so much. Bye now. Good night.